our speakers, Mr. Sorry, the German name is Apfelbach.
Right,
Yeah. And Mr. Marcrelli will introduce to us the technology and all the analysis that to apply the technology to leather scraps and what the analysis that we have to do to apply it and to also have very positive and interesting results of TCR technology we have to apply. And so, if someone has some problem with the English, can ask. We translate after a short part of presentation of Mr. Andreas. Okay, that's better. And so I give the floor to Andreas, and we can start with the description of the TCR.
So, good morning from my side. Thank you for attending this lecture or lessons. I'm going to introduce you with the thermocatalytic reforming. This is it better without a microphone?
I think we should try it now. Yeah.
So I'm going to introduce this technology what we developed within a framework of 16 years. So research takes time till you end up with a brilliant product. First I started to give some background information where I am from or where we are from, what Fraunhofer is. Fraunhofer, this one word, is the biggest research center in Germany. So we have something like 66 research institutes, 24,000 staff members, 2 billion overhead, 2 billion research budget. That's where let's say the mentality or the spirit of Fraunhofer is to support industries, let's say to bring their technologies to market and to solve problems for industries. And I think this is one reason why, let's say, you or most of you are here. You have problems with the waste streams, you have problems with leather scrap, and you think the technology what you can introduce will help you to support, let's say, to find a solution for this problem. Where I'm from, just going back to the country, our institute is in nice Bavaria, so quite green. We have something like 600 employees, and part of the institute, or the biggest part, is in North Rhine-Westphalia. That's a quite famous part. And here in the middle of the green, we do the environmental research where we develop the TCR technology. So it's quite, let's say, 600 people, approximately 600 people, some students, some master students, bachelor students, PhD students. Important, we have something like 14 spin-offs. One of these is dealing with the TCR technology, with the thermocatalytic performance. This is one spin-out. And let's say our budget, of course, is something like 4 million a year. Topics what we are dealing, thermochemical processes. This is where the TCR technology is included. Thermal processes like combustion or in general energy from biomass, thermal storage, recycling management, and this is where, for instance, the part comes into play what to use as solid residues, where you will have the chromium compounds, for instance, included in the, what I show later, the biochar. And this is something where we can find ways with this department in our institute, for instance. And then we have some biological technologies which will play a minor role as wastewater treatment, biogas technologies, and so on, and some department which is called the. So let's talk about the TCR process, the thermocatalytic reforming. We in our institute have 2 plants, one lab scale plant, which has a size like the table, one 30 kilogram brick, which is from the wall to here approximately in the length 3 to 4 meters, where we put through 30 kilograms of feedstock, It's heated electrically because it's a hot process. We have temperatures around 400 degrees, I will explain this later. And this year we are going to install a 300 kilogram. So let's say you can go from lab scale experiments, from small experiments to say, or to investigate how does the feedstock behave. Is the material causing problems with the reactor, with the mechanics? How is the distribution of liquid gases and solid material? Well, our heavy metals, for instance. And then we have a pilot plant where we do long-term tests. For instance, you have research programs where one customer comes with something like 6 to 10 tons, and we run this for 1 or 2 weeks just to let's say, go for business cases afterwards. Yeah? And this unit is more or less a demonstration plant. Will be installed 20 kilometers from our headquarters, and let's say we are now on the way to build it. This will be finished summer this year. So what is this process? So the thermocatalytic process, first of all, which is very important, it's a process where all types of products, scrap, biogenic waste, anything which has a certain energy value is treated under the absence of oxygen. So it's a process where there is no oxygen here. So feedstock falls into through a fluid system where we get rid of the oxygen. Then we have a hot reactor. This is what we call carbonization. There this feedstock is heated to 400 degrees, which means it's let's say falling apart into gaseous products and liquid products and some solid products. Yeah? Afterwards, we have still a, let's say, catalytic reforming. This is at 700 degrees, all under the absence of oxygen. This is important that you don't have oxidation. And then this improves the quality of the gas and the liquids, because you have still, or let's say, the intention was to go for energy, for energy generation. But let's see here more or less that the topic is more or less to get to convert scrap to something which you can use afterwards, or to reduce the amount of material, of waste, or to bring, for instance, this waste streams after carbonization to copper melter or to iron or chromium industry. So what happens? We start with a feedstock under the absence of oxygen. We have to heat it up in this true reactor. Then the feedstock, or let's say the leather scrap, will fall apart into gases, into a liquid, and into, let's say, a carbon source, where you have all, let's say, the metals, heavy metals will be included. We can later talk about ratios. So this is how it looks again. This is just a carbonization reactor. If you have wet feedstock, for instance, sludges, then you add it further, you start with a thermal pre-drying. Yeah? But in more, it's not a big difference if you have a wet or a dry material. So what are, let's say, the parameters of the thermocatalytic reforming? In the steam reactor, we have a temperature of about 450 degrees. In the reformer, we have 750 degrees. We have quite slow heating rates. This makes, let's say, this helps to form liquids which are suitable for engines. Particle size should be a bit bigger than 2 millimeters. It shouldn't be dust, otherwise you have to compact it. Yeah. And the size can be up to 3 centimeters. So we have to treat the scrap in, let's say, maybe with a shredder or something, where you end up with sizes 3 to 2 centimeters, something like this. If we have a high moisture content, like in the sludges, for instance, we have to dry it. In general, all type of biomass is possible. Let's say everything with a certain heating value, even plastics or whatever, is possible to be treated. But in terms of when it's about energy generation, we should have a heating value. When it's just, let's say, about reduction of waste streams, and you don't mind about the energy, then even the heating value doesn't play any role. So these are some feedstocks what we have tested. as I have told you, generally you can use anything which has a somehow a structure, what is not dust. This is all, everything what you can use for this technology. And we have plenty of this, for instance, just about waste streams, no matter if it's bio-waste stream or waste stream from industries. There's plenty of waste streams available worldwide, and let's say just our institute, the aim is to generate fuel without the competition to food. But this is a topic which is, let's say, one of them would be what is a byproduct. Yeah? When you convert your leather scrap or your leather sludges to the products, of course, you can generate energy out of the gases and the liquids. But I think the most important aspect for you is to reduce the amount of waste and to find a solution to get rid of the chromium and without any danger to form chromium fixed salts, but I will talk later about. Yeah, I think it's not so interesting for you what, let's say, the variations, but just to give you some example. When you add 100% of solid feedstock, yeah, or let's say leather scrap, or the leather sludges, depending on the temperature of the reactor, you can form 44% gas, 6% oil, so you have some water as well, processed water. And this is the char where the metals and minerals are contained in the char. So when you have 100%, let's say, leather scrap, depending on the temperature and on the organic content of your product, you can convert the solid to gas, liquid, what you can convert on oil. So let's say something like 50% is directly convertible on engines. 22% of water, this is able to be disposed, but this is reduced as well. And then you end up with 29%, approximately, but this we have to go further in detail, of a solid product, char, carbon, where you have the metals in it. And then, let's say, now we can find solutions for this, let's say, residues again. Maybe you can investigate to go for chromium industry, because we have carbon and chromium salt for it. This might be one solution. Just to show you something about the quality of liquids we can get out of all kind of biomass. So more or less we get as a liquid this dark brown, but if we can do further chemical processes, we call it hydrogen oxygenation, then we end up with a real oil, so something like diesel, for instance. This is possible. So you can convert all kinds of biomasses like straw, sewage sludge, digestate, leather scrap as well, sludges from leather industry, to a solid, a liquid, and a gas, and you can convert this liquid even to diesel-like fuel. Yeah, this is something just about the fuel properties, just to show you that this even is possible to give to a refinery. Heating by use the char what you might get out of your leather. You have something like 20% of ashes, 5% of chromium. The ash and the chromium will be concentrated in the char, because it's not volatile, it can't be evaporated, so it will stay in this char. Depending on let's say, on the temperature, you might upend with a higher ash content, but when you start with 22%, and I assume we leave with 1/3 of char, so then you might end up with 60% ash with all the chromium heating value might be lower. But you still have the chromium in the char, so what you end up with chromium and carbon, and the other minerals like the pigments in this char, and then one can find, let's say, a solution or a recycling route for this residue. Still, what you still have is gas and oil, easy to be converted on PHP engines, so you generate, in addition, out of your disposal, out of your waste, you generate additional energy. And it is something what I would assume it could be a good feedstock for chromium industry. You have green carbon and high content of chromium. When you say you have a reduction of, let's say, 2/3, and you start with 55% chromium in your leather, then you end up with 15% of chromium in this carbon. Let's say framework. Yeah, I don't want to talk too much about the quality of the oils. This would be the route. For instance, more or less the carbon would end up in a metallurgic process, for instance. Other possibilities, but this depends, of course, on the amount of heavy metals. Yeah, you could think about co-generations with this high chromium content. I don't think it's possible. As well as cement or lime industry is not possible. There's possibilities here to bring the chromium back into the recycling to the metallurgic industry. I just want to show you one thing. We are running a truck with our liquids as well, so this is possible as well. So 20% is the liquids of our liquids, we add the biofuels and then we run the truck. This is just might be a byproduct. But what I will concentrate on the biggest question for you is the chromium problem. Yeah? Quite often, I think several trials have been carried out to combust the leather scrap, for instance, or the sludge from leather. The problem is when you go with incineration, these are, we call it oxidative processes, where you add oxygen. And at a certain temperature window, you end up with converting chromium-3 to chromium-6. And chromium-6, of course, is dangerous heavy metal. It's more or less cancerogenious substance. And this needs to be avoided, because otherwise you have to pay high money. So whenever you add high temperature process, something like 400 or 500 degrees, this is the window, and oxygen, then you convert chromium-3 to chromium-6. But this just happens when you are when you add oxygen. Yeah? This is an oxidation from chromium-3 to chromium-6. This is an oxidation. As I told you, the thermocatalytic reforming process is a process where we have no oxygen. Otherwise, the process wouldn't work. So we are free of oxygen. We produce hydrogen, carbon monoxide, and carbon. And these are called reductive agencies. So this ensures that there can't happen any oxidative processes, which means you keep your chromium at least to a chromium-3 compound. Yeah, and then there's still the question, the chromium, as this is not new for you, it's not volatile, for sure it will stay. Hello. The chromium, of course, will stay in the jar. You can't volatile chromium oxide. It's not volatile. It won't go into a gas phase. So it stays and it accumulates in the jar, and this is where we find quite a lot. All of the chromium we will find in the jar. It will increase the concentration because we reduce the amount of, let's say, leather scrap. Because we have gases, we have some of it converted to gas, 40% is converted to gas, to hydrogen and carbon monoxide. Another 6 or 8% are converted to oil, so we reduce the amount, which means the concentration of the chromium in the jar increases to just 50%, if we start with 5%. And there's somewhere you are quite, not quite close, but one can think about using this jar with the chromium and with the minerals as substitute to the chromium industry. And this is where I will, let's say, stop with my presentation as a summary. The TCR process will help, or what will be carried out, will convert residues, like the leather scrap, to gases, liquids. You can generate energy with this, and reduce the amount of, let's say, contaminated material to a jar, which is normally just chromium-3. And we can find further solutions maybe for the chromium industry. So this is where I'm going to stop my presentation. Hopefully it was not too technical. Hopefully you could get some information what is possible for your problem to get solved, to get rid of, let's say, these chromium compounds, obviously chromium-3 contaminated compounds like this strep or these chromium sludges. I'm free for any question. Hope I could support and help a bit, and I'm looking forward to your questions.
Okay, thank you. Probably it's better to finish the presentations and after.
Presentation of
Good morning, everyone. My name is Stefano Macrelli, and I will say a few words in Italian first, and then I will switch back to English and for the presentation. Questa presentazione in due lingue, la potete seguire anche se non siete molto familiari con l'inglese, basta che guardiate tutte le scritte in rosso e praticamente c'è una sorta di traduzione in italiano. Per problemi annotatevi le domande che poi alla fine vi risponderò puntualmente. So, back to English. Hope you don't mind if I'm sitting instead of Andreas. And I'm Stefano Macrelli. I'm a research fellow from the Bologna University, and I work in the department actually in two departments, one for environmental sciences and the other one for industrial research on energy and environment. The topic of the day is the feasibility study. So we saw how interesting results can provide the TCR equipment, but however, we need to carry out a technical study and also economical study to assess the real life feasibility. So with this presentation, I'm going to talk about the steps which are included in the feasibility study regarding the application of the treatment with the thermal catalytic reforming of leather scraps and wastewater treatment sludge in the leather industry. So this is just a brief outline. I will tell you who we are, what we're doing in my department in the University of Bologna. Just say a few words about the collaboration with UNIC, the Italian Leather Industry Association, and also show what are the waste problems for the leather industry. And then I will just end the presentation talking about the several steps of the feasibility study. The feasibility study is composed by laboratory testing, so all the material that we collect from the industry, they will be tested in almost industrial scale or a demo scale, let's say, demo scale of TCR, which process at 30 kilos per hour. And then with those results, a scale up to industrial size is required. Combining results and the scale up then can yield the technical feasibility of the process, and then of course we are interested in the feasibility, the economic feasibility, which is the profitability. So if we can just pay off our costs for disposing of such waste. Just a few words about my department, actually interdepartmental center. It's located in Ravenna, and there are many laboratories and offices that belong to it. you can see probably the underlined 3-1, and that's those are the main laboratory which provide personnel and competencies for the TCR project. So why today this Fraunhofer Institute, University of Bologna, and we are invited by UNIC. So first of all, have to be said that since December 2013, University of Bologna and Fraunhofer Institute started a collaboration agreement. And the reason of this collaboration was due to the industry crisis and to provide need consulting to the industry sector. But it's pretty important also to stress the fact that the collaboration regarded the German technology joined with the scientific competencies of the university. So there are two actors that are almost complementary. And as a university, we could provide innovative experimental analysis of the products and also of the input material, as well as sustainability, so life cycle assessment, environmental management system. That could include also risk analysis and the compliance to the REACH directive, and last a little bit more technical or engineeristic topic, which is a techno-economic evaluation of processes. Okay, and why University of Bologna and collaboration between University of Bologna and UNIC? We had a meeting in 2014, an initial meeting in 2015, and the Italian leather industry have a lot of waste production during their activities, and as you can see in the graph, the percentage or the fraction of the wastewater treatment sludge is pretty high. It varies between 34% and 19%. It must be told that the wastewater treatment sludge is almost impossible to recycle, and whatever is possible to be recycled, UNIC already did a great job. So what you can see there, not in the orange squares or rectangles, it's already recovered within the industry, within the leather industry. So, as Andrea was mentioning before, we had already collaboration with Fraunhofer, who developed the PCR system, and it's particularly interesting because there are no oxidative conditions inside the environment, the reaction. And we know that chromium, it's a very dangerous pollutant if it evolves from chromium-3 to chromium-6 only that time. So we just connected the collaboration, and now we are here today talking about how to recover chromium in the free form instead of combusting it and generating a very dangerous waste. So for this reason, it's needed an evaluation of the TCR treatment and also to highlight opportunities of treating the sludge and also the leather scraps. In this picture, you cannot see the leather scraps because they are just minimal, and the main actually is the wastewater treatment sludge fraction. So in the picture, you can see the overall system of TCR and also the uses of the products. As Andrea said before, there are three products, a gas, an oil, which can be has characteristics similar to diesel, and the char, which is kind of coal. And all the chromium, I want to stress the fact that stays into the char. So why feasibility study is needed, or what are the answers that feasibility studies can provide? So first of all, if the material that we put in the TCR is suitable or not for processing, because Andreas told you before, and the size should be reduced, and also the humidity or the moisture of the material should be in a precise range. Moreover, once we are sure for the suitability of the material, then we treat the material. And now another question arises, which is that a good conversion? Do we obtain a good conversion to valuable products? Moreover, how much energy we produce, or how much energy we produce compared to the energy required to run the process. Since the process is a thermochemical process, it runs at high temperatures, then the expenditure or the expense or the energy requirement is pretty high. So we would like to produce less energy than we consume. It can be feasible because chromium, because chromium is it's a particular ways to handle. Then once we treated the material, another question should be, what are the byproducts, and not only the byproduct? What's the recovery that we can achieve with chromium, and what's the fate or the ultimate uses of the byproducts and products that we produce? Those were mainly technical questions, but now comes the economic question, which is it cheaper to dispose the sludge of the leather or use the TCR system to treat the material, and at the same time obtain also energy and a high-grade fuel? In conclusion, the feasibility study gives answer to the profitability of the investment, since TCR doesn't come for free. Please correct me. No.
Well, it's not 100% free.
No. I mean, any treatment has a cost. We want to evaluate what is the profitability of the money spent in this treatment. So finally, we jump to the steps of the feasibility study. So first of all, as I told you before, we need to achieve experimental data from the leather scraps and the sludge produced in the leather industry, and the data are performed using a demo plant, TCR 30. 30 stands for the kilogram per hour that the machine can treat. The experimental data regarding we can achieve from the experimental test the compositional analysis, the yields, and the concentration of the various chemicals and chemical species that are present in the three fractions, in the gas, oil, and char. As this experiment is not, it's performed in small scale, we needed to scale up to a real industrial facility for treating the waste. And so we need to kind of adapt the results that we took from the experiment before to an industrial scale. That mainly regards the energy, because the TCR30 is heated with electricity, while which is pretty expensive actually, while the TCR300 probably could be also heated with steam or oil or two gases. Yeah, two gases. So combining, as I told you before, the experimental data and the scale up, we go deeper into the engineering design, and we assess the technical feasibility, performing material and the energy balances. And then at the end, of course, we want to reach a number which is could be the payback in years, could be the internal rate of return, could be the net present value of this technology. And then, of course, the document which encloses all those information is a kind of a business plan. So I wanted to give you a little bit more information about each of those 4 steps. Regarding the experimental data, the material must be prepared before the treatment. So size should be reduced and the moisture should be correct. For instance, in the case of wastewater treatment sludges, the moisture is very high, so it should be reduced in order to be treated with the PCR. So, as I mentioned before, but I want to stress again, a drying stage is required. The operating condition, they can vary between 400 and 600 for the carbonization, and a little bit higher for the reforming itself. And the condition will be chosen according to the experience that the front operation had for the different kind of materials. And so what do we get from analyzing those 3 fractions of syngas, bio-oil and biochar? We get the composition of the gas, which is made of hydrogen, carbon monoxide, carbon dioxide, and also methane. And according to the fraction or the composition of the gas, different application might be envisioned. Regarding bio-oil, it's super important the calorific value and also the acid number. Bio-oil could be it's almost suitable for as a drop-in fuel. It should be diluted to 20%, or it should be 20% inside the tank, but it already complies with all the regulation for fuels. For car engines, actually, not just for fuels, for car engines. The last fraction, the solid fraction, the char or the coal, that one recovers the metal, which includes, of course, our chromium. Having done all the composition analysis, we can back calculate the yield. So how much material we achieve as syngas, bio-oil and biochar given our input. And that's very interesting for the economical analysis, technical feasibility. So how we perform a scale up to an industrial scale TCR. First of all, it's very important to know the location where the industrial TCR will be installed, because we can calculate the overall capacity of the TCR, the input capacity, and there can be factory consortia, so the input can be increased, and so probably we need a larger scale industrial TCR or multiple of them. So that's the first factor to be considered, and as I mentioned before, we try to adapt the result obtained from the smaller scale to the industrial scale, and that regards mainly the energy requirement. And during the process of scale up, the increasing the capacity of input material of TCR usually correspond to a lower expense or cost for the equipment and the energy. And that's all for the unit input. And that's due to the economies of scale. So you can achieve a higher efficiency if you usually you can achieve a higher efficiency if your plant is bigger. So it's even cheaper. So it's a good point. As Andrea mentioned before, there is already an industrial scale TCR which processes the 300 kilograms per hour, and the scale up is 10 times compared to the setup that they have in their lab. Technical feasibility. At this point, we needed to adapt our design and integrate the process or the existing process of the facility with the TCR. And that requires, of course, some adaptation, but also some additional equipment. For instance, in the case of drying, you need a dryer. What's the balance of the results? So what you put as input, you get it as output. So nothing is lost because we collect everything. So regarding the material or the products that we get, it's of paramount importance the product ratio. So in this way we can obtain the best technical exploit of the three products, of the syngas, bio-oil and biochar. Regarding the energy use, also it depends on the size of the machinery, of the equipment, but some specifications should comply, for instance, temperature and also voltage. Since the TCR is not running on temperature, you have to probably use saw, there are some screw reactors, so electricity is needed too. Last but not least, that I put also in brackets, it's the regulations that must be complied to regarding the waste use, the emission, plant authorization, so on and so forth. Finally, we come to the profitability analysis. Given all the stages before in the feasibility study, we obtained the results. We consider the results, the scale up and the integration, to do our cost evaluation of the hardware, of the machinery, of the equipment, and it's called CAPEX. But now we need, we have our capital cost, and now we need the running expense or the operating cost, known as OPEX. And that can be given by the economic data, which should be local, and regards, for instance, the waste disposal cost, for instance, for sludge or for scraps, the cost of electricity, of heat, local taxes, also the expected return on the investment that the industry wants to have, as well as the project lifetime, which normally ranges between 15 and 20 years. So now we evaluated all the costs, the capital cost and the running costs, but now we want to combine them into a business scenario. So as the TCR mainly provides heat and electricity, and you could do two things mainly. You can either use it for auto consumption or internal exploitation, or sell it to the grid and to the national grid. So also some business scenarios should be considered, and that gives out what scenario is more profitable for the company. At the end, as I mentioned before, all those information are collected in the business plan, and the business plan is expressed also with several profitability metrics. which will be the payback, the return on investment, the internal rate of return, and then the net present value. So that's it. I want to thank you for your kind attention, and please, if you have a question, both in Italian and in English, se avete domande in italiano, fatele pure tranquillamente alla fine. Grazie.
Now we give the floor to Alessandro lawyer in Rome and expert of crowdfunding initiatives in Italy.
I'm Italian lawyer and an expert in crowdfunding campaigns. But I'm very sorry that this presentation is only in Italian language and my speech the same. So if you want
Qualche italiano c'è?
Qualche italiano c'è?
Sì.
Allora, lavoro per Unic che mi ha incaricato di svolgere una campagna di crowdfunding legata a questo, al discorso che ho fatto fino ad ora relativamente a questa attività che viene fatta invece tra l'università tedesca e italiana. Come la domanda è attraverso quale mezzo Unic riferisce i fondi per finanziare questo progetto di ricerca? Questa è la domanda, la questione. E Unic ha deciso di finanziare questo progetto di ricerca attraverso una campagna di crowdfunding. Il crowdfunding, quindi oggi noi facciamo una piccola presentazione esplicativa per far comprendere in che cosa consiste di fatto una campagna di crowdfunding. Chiaramente fatta in tante fasi, eccetera, però questa che non è la sede oggi per parlare come verrà effettivamente poi sviluppata. Era questo incontro per illustrare il discorso di che cos'è e perché è stata fatta questa scelta. finanziare le idee e i progetti che vengono dal web. Nasce, chiaramente le straniere sanno, più presenti, che di fatto nasce negli Stati Uniti, nasce nel mondo, anche se in realtà il primo tantissimi anni fa è venuto in Italia, però poi tutti se ne sono dimenticati, ma comunque è una forma di finanziamento alternativa che lega appunto al crowd e il funding, cioè il finanziamento che viene direttamente dalla folla, dalle persone che si collegano ad internet attraverso una piattaforma e lì partecipano ad un progetto che viene illustrato da noi, verrà illustrato attraverso dei video, attraverso una campagna mirata, sia sui social sia attraverso altri canali di marketing, per cui cercheremo di incentivare le persone a partecipare a questo progetto sposandone la causa. Il fenomeno chiaramente in Italia esiste da un po' di tempo, come abbiamo detto ce ne sono vari tipi di crowdfunding. Noi faremo quello relativo, legato alle ricompense, ai premi. Adesso vediamo quali sono gli ambiti in cui si è sviluppato, sono tanti, sono per finanziare attività di ricerca, come in questo caso, piuttosto che per finanziare progetti culturali o piuttosto anche per fare profitto, quindi per creare delle start-up innovative.
Okay, sorry. Only a few words in English. Probably English people already knows what crowdfunding is and how it works and which are their mechanism on the web. But crowdfunding is new in Italy, but not in USA or not in Great Britain. A new form, a new system of financing, and to finance everything, I think, from
it's an alternative funding.
yeah, you can use crowdfunding to buy some objects or to finance new activities, even to finance a very big project, also research project, using crowd to sharing the initiatives across the crowd, and they use also a big investments to promote the initiatives, the initiative target.
Quindi di fatto nella logica di quello che abbiamo detto, il grande valore aggiunto per finanziare, per creare della finanza nel sistema di crowdfunding chiaramente viene dal web, che ne è l'interno, che fondamentalmente è lo strumento fondamentale, dove quello che poi è importante è favorire la conoscenza e il consenso delle persone di quelli che saranno poi i potenziali crowdfunders, che insieme decideranno di sostenere il progetto e quindi di dare effettivamente un rendimento, un valore economico al progetto stesso.
Okay. The crowdfunding is an initiative web-based, fundamentally only web-based. Sorry for my English today, and it shares the ideas, and it can support the idea to be known, to be shared with a very large platform of people, of companies, and so on.
With the business plan, particular ways to study. Questa è una rappresentazione grafica su quelle che sono gli aspetti chiavi della campagna di crowdfunding, quindi la scelta di un progetto, il choose of project, i premi e la durata di una campagna di crowdfunding, quindi i gadget e le decoration, perché dobbiamo considerare che una campagna di crowdfunding ha un suo tempo che non è stabilito dal punto di vista legale, legislativo, ma comunque richiede una tempistica che generalmente va dai 40 giorni ai 3 mesi e viene studiata a seconda della situazione particolare legata all'azienda, al progetto, eccetera. Però non si può, per casistica, non si può andare oltre questo periodo di tempo. Un altro aspetto importante è la scelta della piattaforma web. La piattaforma chosen ha website e questa scelta della piattaforma è legata a vari aspetti, quindi è legata al tipo di iniziativa, perché stiamo parlando della ricerca scientifica, si potrebbe fare anche una scelta culturale, stiamo valutando se farla attraverso il sito di Unich, quindi bisogna creare una serie di appeal e capire, come stiamo facendo, qual è la scelta che volete fare. C'è poi la campagna è naturalmente mirata ad un pubblico target, quindi il lancio poi e quindi il sentiment, l'emozione che questa campagna deve provocare è chiaramente legato a chi deve essere indirizzato, quello è un aspetto assolutamente fondamentale. E dopodiché il fine ultimo è quello di raccogliere veramente i fondi. Ci sono poi, diciamo brevemente, ci sono vari tipi di crowdfunding, uno è il donation based, in cui appunto vengono finanziati dei progetti che hanno soltanto un sfondo sociale, quindi per charity, quindi finanziare delle organizzazioni no profit soltanto per ragioni benefiche. Quindi è una vera e propria donation, nel senso che non c'è nulla in cambio, ogni crowdfunder partecipa a questa donazione e di fatto non riceve altro, per cui per costruire una statua in città piuttosto che un progetto particolare per bambini, eccetera, disabili, eccetera, eccetera. Un altro è invece il lending based, questo qui è uno strumento di prestito collettivo, in questo caso la folla, sottoscrive dei titoli o dei contratti di debito e decide a quale progetto aderire tra una lista di progetti che sono già esistenti, quindi siamo nell'ambito che possono essere di prestito peer-to-peer, ma qui stiamo in una nicchia di settore che a noi di fatto non interessa, perché il nostro esempio di riferimento che noi seguiremo sarà il reward based crowdfunding. Qui in questo caso vengono finanziati dei progetti a fronte dell'ottenimento di un reward, di un gadget, di un premio che appunto dovremo decidere quale esso sarà. Il livello poi della ricompensa viene scelto in base al valore della stessa donazione, per cui possono essere fatti veramente dei range, secondo dei tagli di donazione che immaginiamo, ognuno poi si basa appunto riceverà un gadget. Questo è sicuramente nel mondo e in Italia il sistema di crowdfunding più diffuso e più utilizzato, perché ha una sua attività, una semplicità di applicazione tale per cui di fatto è molto amato. Esiste poi un crowdfunding che noi non seguiremo e che è quello che viene definito l'equity based crowdfunding. Quindi l'equity based prevede che ad ogni ricompensa venga riconosciuta una partecipazione azionaria della società che verrà costituita. Qui siamo nel mondo delle newco e delle start-up, che sono poi il mondo delle start-up innovative. L'Italia è il primo paese al mondo che ha disciplinato questo tipo di attività, è regolamentato dalla Banca d'Italia e dal Consiglio, però noi non siamo in questa fase, la nostra è una campagna di crowdfunding reward, per cui a donazione corrisponderà un premio e lì ci fermeremo, proprio perché a seconda degli sviluppi faremo delle scelte successive eventuali che sono ad oggi previste.
Okay. There are different types or forms of crowdfunding. The donation base is a sort of charity organization. Yeah. the reward, the ground, yes, without profitability and the second one is reward crowdfunding. That is the type of crowdfunding to which we are thinking for our initiative on TCR, because our idea is to promote, to support the feasibility study with a reward crowdfunding campaign in order to to obtain the results and the gadget of the initiative. Probably will be the sharing of the results of the feasibility study. And so we are thinking to share with all crowdfunders the results of our campaign.
Okay. E ci sono poi due sottotipi di crowdfunding, qui siamo alla fase dell'ottenimento del finanziamento, nel senso appunto i crowdfunders hanno partecipato alla campagna, hanno donato, a quel punto si deve fare una scelta. E che tipo di crowdfunding vogliamo perseguire, il loro mapping oppure il tool, per cui il finanziamento si ottiene soltanto se si raggiunge il target nel primo caso, oppure si trattengono tutte le offerte dei crowdfunders indipendentemente dal raggiungimento del target, e in quel caso unici aggiungerebbe, come dire, una sua pro quota per raggiungere il budget prefissato di ottenimento del finanziamento. Facciamo dei piccoli richiami alle piattaforme, ai website. Qui chiaramente la piattaforma gioca nell'ambito della campagna un ruolo fondamentale, perché se no della scelta della piattaforma la possibilità di incentivare maggiormente i crowdfunders piuttosto che non può vincere di molto. Però come vi dicevo prima, la scelta potrebbe essere anche il sito della stessa Omnici, però bisogna trattare una serie di elementi tecnici, eccetera. Così concludiamo di fatto dicendo che la rete, il web, è assolutamente l'elemento fondamentale e portante di ogni campagna che si rispetti. E viaggia, la campagna di crowdfunding viaggia con la rete ed è la rete che viene l'ultimo. Chiaramente poi sono i promotori della stessa che attraverso un'attività dedicata interamente per il periodo di durata di tutta la campagna a fare in modo che ci siano sempre maggiori adesioni, quindi con le pubblicità, i video, tutta una serie di attività creativa che è poi la linfa vitale dell'operazione stessa. Questo, ripetiamo, per il tipo di operazione che mettiamo sotto quello del reward. E con questo di fatto chiudiamo questa piccolissima presentazione del lavoro della campagna che svolgerà Omnici.
Questions? Any questions? Please.
Tecnica. Parlo in italiano. A livello poi di power generation, avete testato il syngas, motori termici, su turbine, su sistemi energy?
Allora, first we answer in Italian. Il motore ideale è un motore endotermico, combustione interna, non una turbina, perché nel motore endotermico noi possiamo anche utilizzare una parte dell'olio. Di solito
una combustione.
Esatto, una combustione. Un motore dual fuel. So, the question
Scusi, ma avete già fatto delle prove? Cioè avete uno storico? Quante migliaia di ore avete fatto?
Sì. Tante. So the question regarding the electricity production and which was the tool or the engine to produce either an engine or a gas turbine. And they were also asking how much, for how long actually an engine, a dual engine, has been running.
It's a fuel engines on the TCR 30. We are running now for approximately 1 year. Things.
How many
Quante ore ha fatto?
working hours of
For plant,
100 or 1000.
Enough of the generation
No.
of the
of the
heat
heat
and
and
the
the
engine,
Power generation, electricity and also thermal.
Thermal, yeah.
just have to touch it.
Sorry, 100 or 1000.
Approximately 3,000 hours. Approximately. Approximately.
La potenza del motore. I kilowatt elettrici.
200.
200 kilowatt
200 kW elettrici.
E il rendimento
Allora, 200 kW elettrici, la scala industriale a 300 kg/h. Poi ovviamente dipende per quando si fa lo scale up, se c'è più materiale, magari si mettono tante scale industriali in parallelo, perché sia...
emissione del motore in funzione del gas di sintesi previsto per le temperature di lavaggio.
Come avete fatto le analisi sul fumo?
Infatti Fraunhofer, regarding the emission.
It depends. It depends on the feedstock what emissions you have. For instance, we have worst case scenarios where we use this from digestive, which has a high nitrogen and sulfur content. And when you bring this into this oil, then of course the sulfur and nitrogen is in the exhaust gas, which means you need afterwards an exhaust filter. But it depends what kind of feedstock you use. When you use a straw which has almost no nitrogen and sulfur, then you don't have any problem with the exhaust. So we have to check the feedstock and to see how the oil and gas looks like, and then we see what you add to the engine comes at the end out.
Quindi non sto parlando, perciò avete montato oscillatori catalitici, ovviamente troppo tempo.
Sì, corretto.
For nitrogen we have a
Ma non vogliamo adattarci solo
in addition, there are, because you mentioned beautiful engine. Another option is you just go for a gas engine and just convert the gases on site and collect the oils for another treatment, for refinery treatment. But you have to convert the engine, the gases on site. It doesn't make sense to transport the gas.
applicazioni in Italia.
no, not yet.
Gli unici sistemi sono sul Germania.
TCR 80 is planned to go to Italy. It depends on the contract.
Yeah.
Which engine? MAN or
Which engine?
We have a
Cummins.
Cummins in laboratory. We have a Cummins with the TCR 80. It's only Cummins.
Siete disponibili a fare delle prove con le materie prime che studiamo?
Come Università di Bologna noi diamo solo supporto, diciamo così, tecnico, però tutte le prove le fa Fraunhofer. Infatti l'obiettivo del crowdfunding è pagare queste prove.
Esatto, queste prove sono finanziate attraverso...
Lo scopo in questa prima fase, lo scopo del crowdfunding poi si può pensare eventualmente di estendere, allargare la questione anche poi all'impianto, a un mini impianto eccetera, però la prima fase è proprio quella del sostegno, quindi del finanziamento delle verifiche di fattibilità. Indicativamente si parla di 10-12 mila euro per matrice, per tipologia di matrice, più o meno come range.
Sì, ma in che quantità? C'è una matrice però poi sono 20 tonnellate.
No. Sulle quantità non abbiamo ancora discusso.
Ma in generale...
How many kilos or what is the quantity for the feasibility study of the team?
Sì, dai, ne parliamo di pollina perché...
Collassamento dei metalli.
Se parliamo di pollina dell'intierra oppure di pollina del terquario da Oriole è diverso. Perché la pollina dell'intierra è usi anche una pedaia, quella del terquario da Oriole non so. Se tu hai tutto un altro paio di maniche. Se vuoi chiedere perché visto che è uscito l'argomento pollina, si è pollina da ovaiole, quindi non da galline che...
L'allevamento intensivo che
Esatto, l'allevamento intensivo, cioè le galline praticamente camminano su delle graticole dove poi la pollina scende su dei nastri che viene trasportata verso di stanno, quindi non razzolano la terra le galline.
Certo.
Quindi io non lo so dire in inglese.
Any experiences on hot manure?
Chicken menu. Chicken menu was quite good because it's very dry. More or less, it's
Sorry, is that pure chicken manure?
no. Normally, what is delivered is chicken menu with a mixture of wood or straw.
No.
What 100%?
Not the other one, the pure, not with the wood.
It's 100%. We didn't try. We have to investigate how it looks, but with this mixture 50-50 or what it was quite okay. But one has to look at it. In general, when there is plenty of organic compounds, which should be normally in manure, it's good. The higher the inorganic part is, the less oil and gas you get, because inorganic is not convertible to gas or oil. It stays as a mineral as it is. What we have tried is, for instance, pig manure, works quite good as well. Sewage sludge is brilliant, it creates a brilliant oil, but of course they have a high ash amount in the feedstock as well. Let's say residues from digestate as well, so we have to look at it. Then we can tell you what it is, but normally all this type of excrements are quite good in but it depends on the organic content. We just can convert the organic, the minerals stay the same.
Okay.
Those can be treated as some, just for overview, of also electrical materials and those plastics.
E questo fungaio non hai avuto esperienza con un uso da fungaio? Sono settimane
The use of mushrooms, the ground to...
Let's say, in principle, you can convert anything.
Anything.
Yeah. Thing is, with the mushrooms, it's about the water content. You have to dry it.
No.
It's residues.
Cultivation soil.
Is how much organic is that? This we need to know. If there's plenty of organic compounds, yes.
Yes, one of the interesting metrics, for example, for the leather, scusate, tanto mai sono italiani, sì, c'è stato un attimo di flusso. La terza matrice proprio che entra poi in coda a quelle che noi vorremmo testare con la tecnologia PCR è anche, parlando delle concerie, il cosiddetto indifferenziato. Cioè tutto quello che finisce, per intenderci, con i 150106, che sono imballaggi contaminati e di tutto, proprio perché in virtù della percentuale di sostanza organica, anche dovuta al contenuto plastico che c'è lì dentro, lo rende una frazione papabile e utilizzabile per il PCR.
C'è un minimo di potere calorico della matrice che deve inserire per riuscire a
Più che altro dipende dalla sostanza organica. Sì.
Avete già affrontato il tema autorizzativo in Italia per piazzare un impianto del genere?
Ci stiamo...
Perché no, adesso
Sì.
seriamente, cioè, tutto è stato fatto seriamente fino adesso, però voglio dire, il problema grosso è, posto che questo impianto funzioni, posto che sia il più remunerativo del pianeta Terra, in Italia è facile far passare per le forche taurine del GSE e compagnia cantando.
lascia stare il GSE.
No, GSE.
No.
C'è solo la conferenza dei servizi in provincia.
Ok, il GSE però ti domanda tutta una serie di decisioni che sono queste che stai facendo tu.
Ci può mettere anche un anno e basta.
Sì.
Siamo stati noi che abbiamo fatto una cosa del genere, con le turbine
Fa morire.
di Montebello. 2 anni per mettere giù l'impianto sperimentale con il primo classificatore della cartigliana turbine, 3 mesi di deroga e basta.
Okay, the question is concerning the laws and the long time in Italy to obtain permissions, authorizations, and so on.
Però dottoressa, scusi, se mi permetto, la risposta è dell'Università di Bologna o dagli avvocati di Roma?
No, me la devo tagliare
lui
fuori.
poverino, sì, lui poverino, in Germania dice, mercato dei lavori italiani, ma ha ragione, volevo una risposta da voi due io, se c'è. Perché se mi dite che non avete ancora affrontato il problema, cioè, mi sta benissimo come risposta, perché comunque è dura qua in Italia.
No, lei ha assolutamente, ha pienamente ragione, è chiaro che la risposta deve venire da noi, stiamo facendo anche su questo
State cercando di fare un censo, no?
chiaro, prendendo le giuste misure, parlando con
Avete parlato con il Ministero dell'Ambiente.
esatto, gli enti di riferimento corretti, hanno che stanno poi su insomma.
Perché